charge, and around this charge, let's say at this point, at some r distance, we experienced some, let's say if other charge is there, so we experienced electric force, right? Let's say some other charge is there. So we experienced electric force, and let's say we are we are neglecting this charge, and we are considering this point. So we had this electric field, right, due to this charge. So this charge had these properties, and what are these properties? So this charge had vector property, right? Because this electric force is a vector quantity, and this electric field is a vector quantity. So this charge had a vector property. This is what we did in the previous chapter, right?
Yes, sir.
So now we will talk about. So in this chapter we will talk about scalar property. Right. So first scalar property that we talk about is the electric potential. Right. So the electric potential talks about the scalar properties of the charge. Right. And okay, so electric potential it talks about, and it arises due to a single charge. So a single charge can create an electric potential around. So it arises due to a single charge. But what is the actual definition of electric potential? So to understand the electric potential, right? To understand this electric potential, let us first understand about the work done by the force. So, yes, Mir, Assalamu alaikum. We just started. So we were waiting, and yeah, we have started this second chapter. So just a moment ago, I talked about that in previous chapter. We talked about electric force and electric field. These are vector quantities, so we talked about the vector properties of the charge. Now, in this chapter, we will talk about scalar properties of the charge. And one scalar property of the charge is this electric potential, right? So it is a scalar property of the charge, right? And it arises due to a single charge. This is the electric potential. The definition part, we'll talk about that in a moment. So to understand the definition of electric potential, we need to understand about the work done by the force, right? So let's say we have some object, right? And we apply some force in this direction, right? So we apply some force in this direction, and this is displacing this object. Let's say, so now this object is displaced and it is here. So this has, let's say, S displacement, right? So this has a displacement in this direction, right, guys? So then let's say the angle between the force and this displacement is theta. So this is theta. So what is work done by the force? What is work done? How much is the work done, guys? Can you tell me? Yes. Can you guys tell me how much is the work done? If you displace, if you apply some force on an object and it is
Yes,
getting,
work done is force into S, like force into displacement. Displacement.
yeah. So we are talking about the vector quantity. So we will write it in the form of dot product, right? So work done is dot product of F into S. So this is Fs cos theta. This is the work done, right, guys? Right? Clear, guys?
Yes, sir.
Okay. So now we can have kinds of hoops, right? So now the work done is dependent upon the force applied and this displacement, right? But we can have two kinds of hoops, and two kinds of forces. And what could be those forces? So one would be that force is uniform or constant, right? How do I represent a uniform force or a constant force? So let's say the force is like this 3I plus 2J plus 5K hat. So this is not depending upon any other variable, right? These are some constant numbers. So this type of force is a uniform, right? And then we can have variable force also. So force is varying. So how do I represent that? So F would be something like 3x square I hat plus 2y square z g hat plus 8 x square y square k hat. So you guys can see that this force has these unknowns, these variables, right? So this kind of force is a variable force. Clear, guys?
Yes,
Clear?
sir.
So then, uh, then there are two definitions of work done. So there would be two work, right? One would be due to uniform force. So uniform force, we know that that is F dot S. That is dot. For variable force, now the work done would be F dot ds and the integral limit. Let's say x1 or whatever, x1 to x2 or y1 to y2 or whatever the limits are, right? So these are the two kinds of work. One is for uniform force, the other one is for variable force. Is this thing clear, guys?
Yes, sir.
Now, if we know the work done by these forces, so now we can define the electric potential, right? So the electric potential is defined as the work done in bringing a unit charge, from infinity. This point is very important. From infinity to a fixed point by the external force. Right? So work done by external force. This is very important. Work done by external force in bringing a unit charge from infinity to a fixed point is called electric potential. And mathematically, how do we represent that? So electric potential, this V, this is related as work done in bringing a unit charge from infinity to a, let's say, fixed point P and a unit charge. So this is electric potential. Is this thing clear, guys?
Yes, sir.
And remember, this is the external work done, right? So work done by external. So now let us derive work done, or let's define electric potential by a single charge, right? So electric potential of a point charge. So let us find out that. So what do we have? We have a source charge, right? We are trying to find out the work electric potential due to a point charge. So let's say we have a point charge Q, right? And we have, let's say at infinity, this is a very far away point. At infinity, we have a Q charge, right? So let's say this distance is x, right? So we are trying to find out that how much would be the work done, right? In bringing this Q charge from infinity to, let's say, we are bringing this to this point P, which is r distance from it. And let's say this distance is x. Is this diagram clear, guys? Is this diagram clear?
Yes, sir.
So we are bringing this charge from infinity to this fixed point, right? Now, you guys tell me that, so let's say that first, what would be the forces which would be acting, right? So this is for Q charge, this is positive Q charge. So there would be electrostatic force, right? Force due to electric charge, right, guys? So in which direction there would be this force? Force due to electric charge would be at this point, because this charge will experience the electric force, right? So in which direction the electric force would be? Hmm, Already forgotten the Coulomb's law. Let's say we have this Q1, Q2 charge, and this distance is r. We are trying to find out the force on this charge due to this thing. So where would be the charge? Attractive, repulsive. Where would be the charge? Both are positive. What would be the force on this Q2 charge? Attractive or repulsive? That thing we have done.
Yes, sir. Can you repeat the question? Sir, can you like increase the volume of your mic? It's coming like very low, sir. My volume is at max right now. It's like very low, sir.
My volume is also back.
Wait, sir, 1 second.
Okay, can you hear me now? Yeah.
No, sir, I can hear you. It's just coming very low. That's the only problem, sir.
Okay, so use this,
Mm, I don't know, sir. It's fine, sir. Can you
Now,
just repeat?
now you tell me, is this increased? Am
Yes,
I
sir.
okay? So my question is that we want to calculate. The idea is that we want to calculate the electric potential, right? And we know that the electric potential is related with work, right? So we want to calculate the work. Work is related by force, right? Work is related by force that we have seen, right? And that force should be external force, right? So we are trying to calculate the work done by external force in bringing this Q charge from this infinity to this point P. That would be our work done, and that will give us the electric potential. But I am asking you guys, Arsenal and me, that let's say we have this charge Q2, this charge Q1. So due to Q1 charge, this Q2 will experience an electric force, Coulomb force, right?
Okay, sir.
Where where would that force would be? Attractive or repulsive? Where would that force
Sir, isn't that related to the charge of
be?
the...
These charge are positive, right? These are test
Okay,
charge.
sir, repulsive then, right?
Repulsive, right? So the electric force would be repulsive. Again, same case. This is the electric force. Clear?
Yes, sir.
Okay. Now, if I want to bring this charge, right? Bring this charge from infinity to point P, then I'll have to apply a force equivalent to this electric force, right? But in the opposite direction, right?
Yes, sir.
So this electric force would be in this direction, right?
Yes, sir.
So this would be my F external, right? So my F external is how much? This is minus of F E, right? Is this clear?
Yes, sir.
Okay, so this would be my F. So now I have found my F external, right? I have found my F external, and you tell me that what would be the amount of this electric field? What would be that amount? So what should be the electric force? How much is the electric force? This is the charge. This is the another charge. Separation is x. So how much would be F? Hmm. How much would be F? These are the two charges. This is the separation. So what would be F?
Uh, Q1 plus Q2 by R.
Q1
Q1
plus
into
KQ1 by R
Q2
square.
by R. Yes.
This is the force. This is the Coulomb force. Guys, I forgot the Coulomb force. Please start revising, right? Otherwise, this is the simplest. So,
Yes, sir. It's just biology is so huge, sir. I actually just need to finish that, sir. It's so much there to learn that.
bio.
Yes,
Yeah.
sir. It's so much
Bi-
is there, sir. I don't know how to
Yeah,
finish.
but bio is a really deep topic because physics one is only those forces, right? So physics one, they have same principle, same yeah, so same forces. All these are same, right? But biology has different terminologies, and those like, yeah, that was term. You have to remember all those organs. Then you have these kingdoms. Then you have Lanchai, Lanchai, Lanchai. But what we can do? So we have to carry these along, right? Physics
Yes.
one, biology one, all those. So please make a timetable and give those distribute the times properly. Yeah. So what you can do is that give more time to biology part, but less time. But you guys should give some time to physics also, right? Otherwise, you guys will forget, and if you start again from the beginning, then it will take time, right? Because these are fresh. We are doing it, so you can remember it for long if you revise these questions. Please start. Yeah, so this would be charge is Q, this is Q, so that would be KQQ by this separation is X, so X square. Clear? Is this clear, guys?
Yes, sir.
Good. So, yeah, so that is good. And now you guys see that. You guys see that. Yeah, so this should be equal to this external force, right? So whatever force is in this direction, now if you want to bring this charge from here to here, so we should apply the same force. So this should be equal to F external, right? So now we have found the magnitude of this F external as well. So work done, right? Work done in bringing this unit charge from infinity to point P. That is what we want to calculate, right? So that would be F external dot dr, right? That would be the work done, right, guys? And we know that the direction or displacement is in this direction. F external is in this direction, right? So then these angles are 180 degrees. So this would be F external dr and cos of 180. So this cos of 180 degree is minus, so that would be minus. And limit is from infinity to point F, right? So this is from infinity to point F. So minus infinity to point P is R, right? This distance is, so P is R distance away from. So I should write it. Cool. Now we know what is dr. Dr is dx, right? F external is k q q by x square, right? So we know that this k q q we can take it outside, and this is the integral infinity to x r and 1 by x square dx. So what is this integral? You guys tell me. What is this integral? Guys, tell me. What would be this integral? Yes, guys, what would be this integral? Guys, I have already in AC we have done this already. This integral we have done, and this is very important integral. You guys remember the integral? All guys have important integral also. The integral of x
Uh,
n. Yeah, this is n x n plus 1 divided by n plus 1. This is the general, right? You guys remember this thing? And there were some constants, so we ignore that constant. Similarly, this is x. 1 by x square is how much power? What is the power on x? If we take it in the numerator, minus 2. This is, so if we take the power in the numerator, this becomes negative, right? So this is the integral. And if we match it with this, so we have n which is minus 2. So,
x minus 2 plus 1
yeah,
divided by minus 2 plus 1
yeah,
plus c then.
yeah, plus c
So
we
it will
ignore.
be,
Yeah, plus c
yes,
we
sir.
ignore.
So it will be minus x minus, yeah.
So x minus 1, we can write this minus, we can write into the numerator. So this is this thing. And x minus 1 is, I can write this as 1 by x, right?
Yes, sir. Yes, sir.
So,
Minus 1 by x plus c, right?
so plus c we ignore, right? Because we have a definite integral, so we can ignore that part. So this would be y minus 1x squared. This would be this integral, right? So now we have what is thing? And integral is minus 1 by x r infinity, right? So this minus we can take it outside and this would be positive. So this is k q q and 1 by x r and infinity. So first we have to put the upper limit. So function is 1 by x. If we put the upper limit, so this would be 1 by r. Then if we put the lower limit, so that would be 1 by x is infinity, right? So what is 1 by infinity? 0, right? So
Yes,
then
sir.
this is kqq by, right? And this is our work done in bringing a charge from infinity to a fixed point. Now, what was the definition of electric potential? This was work done in bringing a charge from infinity to point B and a unit charge. Whatever charge we are bringing, this is kqq divided by q and r. Qq will cancel, so we will get electric potential as kq by r. So this is the electric potential of a charge q at a distance r from it. Right. So if we are calculating v at this point, so v at this point would be kq by r. Is this thing clear, everyone? Yes, is this thing
Yes,
clear?
sir.
Okay, so you guys please note it down these things, and then we will talk. talk about, yeah, we'll do one question, very simple question, and then we talk about other things.
So scroll down.
Scroll down. Up there is
Yes, sir.
nothing.
I noted this like at the starting a bit, like the first few parts. Yeah, so this
Yeah,
about
this is the topmost part, right?
yes, sir. I noted that.
Yeah, you have noted. So, Mir, what about you? Did you note down this part? Then,
Yes, sir. This part.
and then so we understood that what is work done, and from work done we have calculated the electric potential, right? So what is the
Yes, sir. Scroll down.
always remember this electric potential is when we bring the charge from infinity to a fixed point, right? And by the external force, not the electric force. We are applying the external. Yeah, whenever you guys want me to scroll down.
Yes, sir, scrolling.
Yeah.
Yes, sir. Yes, sir, done.
Then okay. So me, what about you noted? Yeah. Okay. Yes, this was about the electric potential due to a point charge. So always remember that if you have a charge Q and you want to calculate the electric potential due to this charge at some point, so that would be simply kq by r. Okay. And this would be a scalar quantity, so we don't need to think about the we don't need to think about the direction. So the second point is electric potential and point charge. Right. So how much would be this thing? So let's say we have this uh, point P and we have these charges. So let's say Q1, Q2, Q3, 4, 5, and so on. Let's say Qn. So we have n point charges. All these distances are R1, R2, R3, R4, R5, and Rn. So the potential at this point, this would be KQ1, or let me write it properly. This would be V1 plus V2 plus V3 plus so on plus Vn. Where V1 is how much? This is KQ1 by R1 plus KQ1 by R2 plus so on KQN by Rn. So this would be the potential due to multiple charges at a distance at a point P. So electric potential due to n point charge, it says that the potential due or potential at a point due to multiple charges would be the algebraic sum of all the individual potential of those charges. Right. So this is what this principle is, right? So VP would be sum of all those potentials. So let's say, for example, if we want to calculate, so let's say if we have this square, right? If we have this square and we want to calculate the potential at the center. So this has charge Q, this has minus 2Q, this has minus Q, and this has 2Q, right? And we want to calculate, so not, let's say, right? And we want to calculate the potential at the center of this square. So let's say this length is A, right? So we know that how much would be this length, guys? Let me just name them. So
Sir,
A,
your voice is lagging a lot, sir.
my voice is lagging. Is it clear now? What is happening? Is this clear?
Yes, sir. It was just lagging a bit in
Yeah.
between, sir.
Oh, yes. Oh, good. So then we have to find out the potential at O point, right? So we know that this would be equal to how much? This would be AO plus BO plus CO plus DO. This would be the potential length, right? And you guys tell me that if this is A, this length is A, this length is A. So what would be AC? AC would be how much? That is a hypotenuse, right? This is a square, so this is 90 degrees. This is perpendicular, this is base. This is hypotenuse, so that would be perpendicular square plus base square. This would be 2a square root, which is root 2a. But we want to find out these distances. So AO, which would be equal to CO, which would be equal to BO, which would be equal to D. This would be half of this AC, right? Because these are bisected. All these diagonals are equal and these are bisected because this is the square. So this would be root 2a by 2. Is this thing clear?
Yes, sir.
Yes, guys, is this thing clear? Okay, so now let us now let us find out what is, and for a single charge that is k cubed by r. So k q charge is how much? That is q. R is how much? A, and by 2, so this goes over here. Right, so this goes over here. So right, this is VA. VPO is how much? Again, K Q by r, because we are not bothered about the direction. That is why this is very easy, right? Because if we would have calculating the electric field, then we should have thought about those directions, right? Uh, repulsive, attractive, all those directions. That kind of question we have done. But let us talk about this medium. So that is K. Charge on B is minus 2Q. R is there. That is root 2A, and I will write 2A. So minus 4K cube by K. What would be PCO? So this would be K. Charge is minus Q divided by same distance. This is minus 2K cube by, and then we have VD. This is K. Charge is 3Q and root 2A by. So this is 6K cube by. So these are the values, and now we have to sum them. So VP or VO we are calculating. That would be uh, KQ by 2A minus 4KQ by 2A minus 2KQ by A plus 6KQ by A. So 2KQ by root 2A minus 2KQ by cancel. This is 6 minus 4. So 2KQ by root 2A. So if we simplify this thing, so this is 2KQ by A. We have to rationalize this thing. So root 2. So this would be 2 root 2 KQ, and root 2 is 2A. So 2 cancel. So PO would be root 2 KQ by. So that is the potential at the center. So in this way, we use this idea of multiple charges, right? So that is what we have done. So we calculated the potential at this point due to multiple charges. So we had 4 contribution. So we wrote those 4 contributions, and then we simplified them. So you guys please note it down, and if you guys have any doubts, please ask. Please tell me if you guys have doubts. Otherwise, please note it down.
Sir, I'm done.
Yeah, you have Neil, you also respond, please, right? If you have any doubt, please ask me. Because yeah, if you keep that doubt to yourself, then in the exam, if these questions can't show, that will be trouble, right? Yeah, whenever you guys want me to slow down.
Yes, just a bit more and it'll be done. Yes, sir, done scrolling. Yes, sir, done.
Okay, so now what did we do? We understood that electric potential is work done by the external force, right? An external force is negative of the electric force. And then we, using the idea of work done, we calculated the electric potential to point charge, and then we found out that it is kq by r. And after that, we calculated the potential due to multiple charges. So now let us calculate the potential. Third one is potential, electric potential due to a dipole. So this dipole will never leave. Right. We talked about dipole in the first chapter, and this dipole is in here. So, what was the dipole that we understood? Dipole had same amount of charge but opposite polarity, and they had some very small separation at A. Right. This was the separation, and then we calculate the potential, let's say, at this point. So this is making an angle theta, right? And we want to calculate the potential. So, what calculate this. And then we want to calculate the potential due to this thing. And this is point B. Let's say that this distance is R2, this distance is R2. Okay, and if this is 2A, so this would be A, and this would be A, right, guys? So the idea is that what we will do is that we will extend this line, we will extend this line, right, whatever this line is, and we will draw perpendicular here. So let's say this is A, B, and this perpendicular is M, and this perpendicular, so from here we will draw the perpendicular. So this perpendicular is N. So we have to understand what is this part. Is this thing not clear? Is this diagram clear, guys?
Yes, sir.
Yeah. So again, what did we do? We had so we had a dipole, and we wanted to calculate the potential at this point. Right? Then we joined this thing, and in the middle we have this point. In the middle, this is making an angle theta. So what did we do? We have drawn a perpendicular from this point, and we have drawn perpendicular by extending this. So perpendicular this, perpendicular this. Clear, guys? Because this part is very important.
Yes.
Okay. Now, can you guys tell me that this is A, right? This is a triangle, let's say O. So we have O and B triangle, right? We have O. O is this part, right? And then we have this perpendicular N, right? So, and then we have this. So this is the diagram, right? And this is the theta from O, right? Is this thing clear, guys? If it
Yes,
is
sir.
if it is not, so let me draw the same way as it is. So this is the diagram, right? This is theta. This is O. This is B. This is 90 degrees. So we have perpendicular, we have base, we have hypotenuse. What is this thing? Between these three, what is this thing? What is this thing?
So this is the which side? Hypotenuse.
Hypotenuse, right? So identifying the hypotenuse is always the easiest one. Whatever is the 90 degree, whatever is the 90 degree opposite to that one is always the hypotenuse. So This is 90 degree. Opposite to that is yes, absolutely correct. This is hypotenuse. And whatever angle we are taking, so that ray is called the base, right? And opposite to the angle is perpendicular. Clear? Is this clear, guys? Clear?
Yes, sir.
Okay. So now we have this ON, we have this OB. We have base, we have hypotenuse. What trigonometric identity relates base and hypotenuse? What relates that? What relates base and hypotenuse? That is 10th level question. Base and hypotenuse. We have three trigonometric ratios. Sin
Yes, sir.
theta,
Pythagoras theorem and this.
Pythagoras theorem relates all these PBH. I am
Yes,
asking that what trigonometric ratio relates base and hypotenuse?
sir.
What is
Base and hypotenuse.
B
Like,
by H? Base upon
yes,
hypotenuse.
sir.
Base upon hypotenuse. What is that?
So based upon hypotenuse, it's like cos, right? Like sine, cos, and
So sin theta is perpendicular by hypotenuse B by H. Cos theta, as you are saying, B by H, right?
yes, a cos theta, right?
So cos theta is B by H. Okay. So now what am I trying to get? Where do I get this thing, right? So where do I want to get? So I want to calculate this ON. This base I want to calculate because hypotenuse I know that is A. So ON I want to calculate. ON is this B, right? So B would be H cos theta. So B is ON. So ON would be H is A cos theta. So this thing is A cos theta. Similarly, you guys work out this would be A cos theta. Clear, guys? Because this is again theta. Clear?
Yes, sir.
Okay. So now if I want to calculate the potential. So potential will have two contributions. Because how many charges are there? This charge, two charges. So there would be two contributions. VAP plus VBP. Right? Clear, guys?
Yes, sir.
Yeah. So then, and we will use the approximation that this PB, this is nearly equal to this PN. This is one approximation we will use. We will also use PA that is nearly equal to this PM. Right, so these things we will use at a later stage. So VAP, how much is that? That is K minus Q divided by R2. Right, sir? Right.
Yes,
Similarly,
sir.
similarly, this would be how much? KQ divided by R. So this, this is what we are calculating, right? So let us, and now we know that R2 is nearly equal to, so this PB or PB is R1, right? So R1 is nearly equal to P. This is one thing. R2 is nearly equal to P. So let us find out that. So from here to here, this distance is R, right? This distance is R. This is R2. This is R2. From here to here, this O and P. That is R. So can you tell me what would be NP? PN would be how much? PN would be how much? From here to here, that is R. So from here to here, that would be how much?
Sir, it will be around
So total,
R1.
yeah, total is R. From here to here, you have A cos theta. So I am asking that what would be this thing?
R minus A cos theta.
So R minus A cos theta, absolutely correct. That is what I was asking, right? PN, right?
Yes, sir.
OP, we know that is R. So OP is, let me write it some. OP is R. Okay, so PN is R minus A cos theta. What is PM? What is PM? Total is R. From here to here, that is R. And this is OM, right? So PM is OP plus OM. So that would be R plus A cos theta. Let me write this PN as, because this would be more clear. So let me write this as PN as OP minus OP. That is more clear, right? Okay, so now we have found out all these values. So we will put these values in here. So this is minus KQ and R2 is PM and R1 is PN. So this is, let me write it in this way, negative 1 in this side. So KQ PN minus KQ PM. So KQ I can take common outside 1 by PN, 1 by. So this would be how much? KQ and Pn is how much? Pn is R minus A cos theta. And Pm is R plus A cos theta. So now we have to simplify this thing, right? Let me write it in here. So KQ, we have to take this LCM, A minus B, A plus B. So A square minus B square, right? And then this will go in this side, R plus A cos theta, minus of this will go in this side. So I will have to take bracket. So KQ and this is R plus A cos theta minus R plus A cos theta divided by R square minus A square cos square. R will cancel. We know that this R is very greater than A. So this part we can neglect, right? So I should write it in here. Because, yeah, so let me write it. R is. So this is how much? KQ, A cos theta is 2A cos theta divided by, yeah, where is what did we do wrong in this? This is R square. How we are getting R square? Yeah, this is correct. Right, so A and yeah, that is correct. Okay, so this is right. This is the potential. And now you guys will tell me that what is 2AQ? What is this thing? Please go down in your memory lane and tell me what is distance into the charge. What is charge into separation? What is charge into separation? In the electric dipole, we talked about this.
The charge into separation is dipole.
That one, yeah, what is the name of that one? Dipole moment, right? Strength of the dipole,
Yes, sir. Yes, P is equal to AQ.
right? So this 2AQ is P, so that would be K
KP cos
cos
theta by
theta
r
by
square.
R. So that would be the potential due to dipole, right? And do you guys remember what was the electric field due to dipole? So that was something Kp by Rq, right? So we had this R cube, now we have R square. And there was this 2 for axial part, equatorial part, there this 2 was not. But that we talked about. Okay, so this would be the potential to what time? Is this thing clear? You guys have any doubts? Yeah, what did, let me recall that thing. So we made this diagram, right? This was the diagram. So this was the diagram. Let me again. So we had this minus q, we had this q, and we wanted to calculate the potential due to dipole
Three.
at r distance from here. So this was our aim, and it was making an angle theta. So we got that this is kp cos theta by r. This is what we got, right? So this was the idea, and what did we do? First, we found out that what is this ON and OM. We found out that we approximated that this R1 is PN, this R2 is PM, and then we wrote we found out these values, and then we used the idea of multiple charge, and then we calculated the potential, and then we got this was the idea. You guys, please note it down. And if you guys have any doubts, please ask me. Right? Please ask me if you guys have any doubts. And this derivation is very important, right? Practice this derivation many a time.
Yes, sir. Sir, can you scroll down? Like I'm done with this derivation, sir.
Oh, you have already noted it down. But what about Mir? Mir, what about you? Did you note down this part? Yes, Mir, what about you? What what is happening, Mir? Are you there?
Yeah, sir.
Yeah, did you understand this part? Did you
Yeah,
note
sir.
down?
Yeah, sir.
Good, good. Please respond. I thought you got bored and then you slept. Respond. Please, whenever you have any doubt, yeah, please note it down. And after this class ends, you guys have this class of this. So whenever you guys leave this class, please attend that class.
Yes, sir.
What did we do? We talked about uh, work done due to external force. And from that idea, we calculated electric potential, and using that thing, We calculated the electric potential due to single charge. Then we talked about electric potential due to multiple charge. And then we talked about electric potential due to time. So now, as you guys remember, that dipole had two positions, two special positions. Do you guys remember that? What were those positions? You guys remember? You guys are not revising, that is why you guys have difficulty recalling. So dipole had two positions which were axial point and equatorial point, right? Again, so that
Yes,
part,
sir.
that
Sir,
part,
axial point and equatorial point.
yeah, axial and equatorial. The same line is the axial, vertical line is the equatorial, right? Whenever you guys have noted it down, that. And this time you have done a beautiful homework, right? So your handwriting was very good. Marcela, why were you hiding those handwriting, right? In the earlier, in the earlier papers, I couldn't understand what were you writing.
Yes,
The
sir.
last, the last homework you have sent, that is very neat. Mir, I will urge you as well that please send those homeworks, right? Those are for practice purposes, right? When you do those calculations.